15 positive integers is equal to 1240. So let me quickly tell you the longer way to answer this question first. What is the sum of the square of second 15 positive integers? If you have a question like this, so let me quickly write it. So 16 is square plus 17 is square plus 18 is square and so on. It's going up to 30 square. So the first method is because we have some given information and we want to utilize that given information because GMAT does not give you any information that is redundant. So let me write down all the numbers in this way. 16 can be written as 15 plus 1. So it becomes 15 plus 1 is square. 17 becomes 15 plus 2. So I can write it 15 plus 2 is square. 18 can be written as 15 plus 3. And that ways I'm writing every other number. So the last number will be written as 15 plus 15 and the square of it. Now I'm just opening all the squares using the property a plus b whole square. So as we already know that a plus b whole square is a property of a square plus b square plus 2ab. I'm going to use that. So the first expansion becomes 15 square plus 1 square plus 2 times of 1 into 15. Now the second part becomes 15 square plus 2 square plus 2 times 2 into 15 and so on, and the last becomes 15 square plus 15 square plus 2 times 15 into 15. Now we have to systematically arrange all the data. So I'm just using the color coding. These 15 square will come here 15 times because we have 15 terms here. So when I add all these 15 square, I can write 15 times 15 square. That's the first thing. Now the next color coding I'm using is for 1 square, 2 square, up to 15 square. So there is another bracket that leaves me with 1 square plus 2 square plus and so on. It's going up to 15 square. And the third color coding I'm using for the last part. 2 times 1 times 15, 2 times 2 times 15, 2 times 15 times 15. So when we add them, then 2 times 15 can be taken as common because 2 into 15 is coming common in every number. And finally, what are we left with? 1 plus 2 plus and so on up to 15. So now we have these three things that we can comfortably find out. 15 square into 15 is in a way 15 cube. So we can find this out. Sum of 1 square to 15 square we already have been given is 1240. And the last thing is 2 times 15 times. It's a simple arithmetic progression. Or we can just find out the sum as 1 upon 2 n into n plus 1. Where n is 15 in this case. So I can write 1 by 2 of 15 times 16. So now using this we can find out the answer comfortably. That's one thing. Let me quickly take you to the second method as well. The second method is knowing a property. The property is the sum of squares of n consecutive integers. So this property says that 1 square plus 2 square plus up to n square can be given by 1 upon 6 n plus 1 times 2n plus 1. If we knew this property, we could simply have written that sum of 16 square to 30 square can be written as sum of 1 square to 30 square minus sum of 1 square to 15 square, where to find out the first sum we can use the property which is 1 over 6 30 times 31 times 61 minus sum of 1 square to 15 square we already have been given, which is 1240. So using this calculation, once again we could have figured out the answer. As we can see that the unit digit is going to be 5. So obviously A and B option can be ruled out. Now I'm just trying to take a small shortcut. So we have 5 times 31 times 61. Either we'll have to multiply them all together or we can do some approximation. 60 times 30 becomes approximately 1800. 1800 multiplied by 5 becomes approximately 9000. Out of 9000 we are subtracting almost 1240. So the answer comes out to be option D. So either way you solve it, you get the answer is going to be the same thing.